All right, so again, domain is just your x values. So we just write our x values in the solution sets, preferably from smallest to largest. So our smallest x is -2, 1, and then 3. And then our range is the y values, again, listed from smallest to largest in our solution steps. So smallest y is -1, 4, and then 5. Now, if we look at that on a graph, if I plot 1, 5, if I plot 3, -1, and -2, that means if we have a graph that is just points like that, okay, we call that a discrete graph, we can state the domain just like we do with ordered pairs. Okay, so today we're going to see some graphs that are just points. The way we write those domain ranges is just by writing out the x values for each of those points, writing out the y values. So you could essentially just, if you're starting with a graph, you could essentially write each ordered pair out and then just do the x's and y's, or just write each x and y out. It's up to you. All right. Any questions from last night's homework? All right, then we're gonna work with domain and range a little bit more today. So domain and range from a graph is what we're gonna look at right now. So as we just said, if the graph is discrete, remember discrete just means the points, like we just saw. The domain is the x values right now, the range is the y values right now. Same as when we did ordered pairs. Okay, so that's just what that part says. All right, when we're doing domain from a continuous graph, all right, so continuous graph is where you're connecting the points. So the domain is all possible x values, like we talked about. If the graph is continuous, you're going to need to use interval notation, because if the graph is continuous, you're saying what are all the possible x values, including all the decimals. So you can't write it out like we did the bell ringer one, because you'd be skipping over all those decimals if it's a continuous graph. So you're going to use interval notation to state the smallest x value, so that's saying how far left the graph goes, and then you're going to state the largest x value, which is how far right the graph goes. And we can just use our interval notation to state that. And then our range is all possible y values. So for a continuous graph, again, you're going to use interval notation, and you're going to state the smallest y value, which is how far down the graph is going to go. And then you're going to state the largest y value, which is how far up the graph goes. All right, so here's checkpoint 8. It says identify the domain and range. Notice these are discrete graphs, or sorry, these are continuous graphs. We are connecting points here. So as we go and do this, for letter A, for our domain, we're saying how far to the left does our graph go? So we could essentially take this, and this is the farthest left that graph goes, right? What x value is that stopping at? The furthest left there. -2. So that's our first one. It does have a closed dot at -2. So we put a bracket with the -2. Then we have to figure out how far left does our how far to the right our graph goes. So I can move this. The furthest right it goes is right there. That x value is at 1. And again, we have a closed dot with that, so I'd put a bracket there. So by us writing the domain this way, it's saying every number, including the decimals, between -2 and 1. And that's what we have to write when it's continuous, because these include all our decimal x values in there. Our range is then the y values. So we always go with our lowest first. The lowest this graph goes is right here. What y value is that? 0. Our highest that our graph goes is right here, which is a y value of 3. So we're saying all numbers, all y values between 0 and 3. Letter B is similar, but now we have an open dot on the left and a closed dot on the right. Remember, an open dot means what? What's the difference between an open dot and a closed dot? If we're an open dot, does it actually equal that number or not? No. So when we go with the domain, the furthest left we go is right here, which is -2, but again, we have that open dot there. So that just tells us that we're getting really close to -2, but not touching it. So I'm going to put a parenthesis with that instead of a bracket. The furthest right we go is right here, which is +1, and there's a closed dot with that, so it would have a bracket. And then for our range, how low is it going? Lowest we're going is -1. Our highest is 2, but we have an open dot on that 2. So it would be a bracket with a -1 and 2 with a parenthesis. Now letter C is what we call a step function. Notice it's like looks like steps. It goes from here, up there, up there. So our domain, we're still looking how far left and how far right. So how far left are we going? Furthest left we go is -3, and that's a closed dot. As I'm going to the right, even though there's an open dot here, there's a closed dot at the top. So there is a value at -2. Same thing, I go to the right some more. Even though there's an open dot at -1 down there, there's a closed dot there. And this is the last number that we have, which is at 0. So it is including all numbers from -3, all x values from -3 to 0. But because there is an open dot at the 0, there's no closed dot at the 0, we'd have to put a parenthesis there. But it includes every number from -3, including -3, up to 0, but not including 0. The range is a little tricky because as I go down here, the lowest this gets to is -3. Do I have any values in this area here, though? Do I have any values in that area? No. So my next value is here at -2. There's no values here. My next value is -1, and there's no other values. So am I going to write this as an interval, or am I just going to write out the y values that we have? Do we have decimal values in this, or is it just strictly a couple of y values? John? So we can't include, that's what I was saying, we can't include the decimals here because there's nothing in this area here, there's nothing in that area there. So we're going to have to write this as a solution set, kind of like the bell ringer one. So one of our y values is -3. What's another y value that we have on there? -2. And another y value we have is -1. Again, because we're not having those decimals, we just strictly have 3 y values in this whole thing. There's no decimals. We're just writing it like we did the word pairs. All right. All right, and then the last one we're going to look at here is this one here. And it says to do a couple of things. Well, we'll come back to that. So right now, if I'm finding the domain and range for this graph here, this dotted line represents a vertical asymptote. Okay, if you remember asymptotes, it means they're lines that get close to but you never touch. So it says it's getting really close to this vertical dotted line but not touching it. Same thing horizontally, it's getting really close to this line but never touching it. So the way we do domain and range for these is a little tricky. So we're still saying, all right, how far left does our graph go? And there's an arrow on this side. So how far left is it going to go? What number means you go on forever. Good. And if it's going to the left, what kind of infinity is it? All right. So we're going to start off by saying negative infinity. Now, as we keep going through here, again, it's never touching this value. This value is at 1. It's getting really close to it, but not touching it. So because it's getting really close to it, I'm going to put a 1 here. But does it ever touch it? No. So how do we write that it never touches it? Parenthesis or bracket. I'm going to put a parenthesis. And then I'm going to make a second inequality. So I'm going to put the union symbol, kind of like when we did inequalities before. And I'm looking at this one now. So this one is getting really close to 1, but on the opposite side. So I'm just going to put a parenthesis with a 1. Because again, it never touches 1, but gets close to it. And it goes to the right forever. So right forever means positive infinity. Similarly, with our range, the lowest it gets to is negative infinity. And then as we're coming up, the bottom part of this graph is getting really close to what y value? 0. But does it touch 0? It does not, so I'm putting a parenthesis. We put our union symbol. And then I look at my second one. Again, as this is coming down, it's getting really close to a y value of 0. Doesn't touch it though, so we have a parenthesis, and then it goes up forever. So sometimes, if there's values that are excluded, you got to write 2 separate inequalities or 2 separate intervals like we did there. All right, so keep that in mind. All right.